Welcome back. This is Mr. Wakefield, and we're looking today at adding and subtracting fractions. It's listed down here halfway down the page because this concept of least common denominator is going to be very important in the process of adding and subtracting fractions. Just a reminder, when we do multiplying and dividing fractions, what I'm showing you here from a different video, worksheet from that, you didn't need to do anything as far as making something the same. We just went through the process of multiplying and dividing the fractions. Okay, nothing needed to be made the same. However, when you are adding and subtracting fractions, though, the denominator needs to be the same before you can do anything else. Okay, you cannot add and subtract fractions where the denominator is not the same. For example, look at these two fractions that are going to be subtracted here eventually. Okay, the denominators are not the same, so I can't do 11 minus 7. I can't do any kind of subtraction at all until those denominators are the same, and they can be made the same. How do we make them the same? By doing the concept of the least common denominator. Now again, from a different video here where it was discussed how to factor and then identify factors so that you can cancel. Okay, the way you treat single term factors is different than the way you treat multiple term factors, which is the reason why I used green and red underlining there, green for single term and red for multiple term factors. It's going to be a very similar thing here. This is the lowest terms concept right here, where you put fractions in lowest terms, and there's the multiplying and dividing again, which was very similar to that. But when you are finding the LCD, it's the same thing where you have to start off the problem with factoring and then identifying each factor with the red and the blue. The red and the green. Again, you don't have to use red and green. I'm just going to do this in the video to make it easier for you to follow along. Now, before we do that, however, sometimes we have denominators that are just single terms. I want you to pretend like all of these different polynomials here, including these two small polynomials, I want you to pretend like they're denominators, okay? Since we're just trying to find the LCD right now, I'm not going to make a big fraction out of all of these things here, okay? Just pretend like these are denominators and we're trying to find the least common denominator, okay? So how do we find the least common denominator if both of the denominators are just single terms? Okay, how do you do that? And it's going to be different when you have bigger denominators here in problems B, C, and D. But when you have single term denominators, what you do is you start out with the coefficients. You pick the biggest one. And then remember, least common denominator is the same thing as least common multiple. Okay, least common multiple. The key word there is multiple. Okay, it's the least common multiple of the denominators. Okay, that's why they call it least common denominator. Least common multiple of the denominators there. What is a multiple? Multiple is, like, for example, if I said, hey, what are the multiples of 24? The multiples of 24 in your calculator will help you out with this. 24 times 1, 24 times 2, 24 times 3, 24 times 4, and it just keeps on going. How far do you have to go? It all depends. You keep on going until you find a number that is a multiple of the other coefficient that you have. Okay, now how do you figure that out? Well, with multiples, okay, what you do is you divide the multiple by that other coefficient to test it to see if 15 is a multiple. Okay, so for example, 24 divided by 15, that doesn't divide evenly. Your calculator will confirm that. Okay, 48 divided by 15, if you put that in there, you'll get a decimal. It won't be a whole number like 1, 2, 3, 4, one of those numbers. So therefore, it doesn't divide evenly. 72 divided by 15, your calculator will also tell you that that's just a decimal. Same thing with 96 divided by 15. However, the next multiple, 24 times 5, is 120. If you put that in your calculator, 120 divided by 15, that will be equal to 8, a whole number. It divides evenly, in other words. So therefore, that's what you do. You take the bigger number, you list out its multiples until you find one that also works for 15. Therefore, 120 is common. It's a common multiple, okay, of 24 and 15. All right. It's the least common multiple because I start out with the smallest possible one, and then I worked my way up, okay, for 24. All right. And so that's why that's the least common multiple. Now, that's just the coefficient part of the least common denominator. I'm going to put it in there. Now, for the variable part, that's the easier part. The variable part, it's actually the opposite of the greatest common factor. Just a reminder, when you do the greatest common factor and you have single terms, all right, that you're looking at, you pick the smallest exponent. But with LCD, least common denominator, okay, because of the fact that multiples are bigger than the numbers you're looking at, 15 and 24, whereas factors are smaller, it would make sense then that the least common multiple or the least common denominator would be bigger, okay? And that's why 120 is bigger than 15 and 24. Okay, so in the same way, and with GCF, greatest common factor, we took the smallest exponent. Because the numbers are bigger here for multiples, it would make sense that we would pick the biggest exponent, okay? X to the second, X to the first. The biggest exponent is X to the second. Now, if there had been another variable there, then you'd have to do the biggest exponent for that one as well. But since X is the only variable, we just bring that in there along with the 120. And make sure to say that it's being multiplied, 120 times X squared. So again, in review, you do the coefficients, okay? You then take the biggest exponent of each different variable that you have. We only have X here. And that's how you do what, you guys? That's the steps for doing single term denominators when all of them are single terms. Not just one of them, but all of them. Now, in problems B and C and D, again, just like with when you are putting a fraction in lowest terms and you have more than one term on the top and bottom, all right, it is true in that case that you have to factor everything and identify the factors, okay, and that's what I did the underlining here in this particular worksheet. You have to do that before you can do anything else. It's the same thing when you have more than one term in your denominators and you're trying to find the LCD. When you have more than one term in your denominators, you gotta factor and identify your factors first before you can do anything else. Now, this has a GCF of 1, so I'm going to skip the GCF step, and then you can see that this is y squared minus 2 squared. So using the a squared minus b squared formula, which is the only formula you need to be concerned about when you have two terms at this point in time, okay, a squared minus b squared, what is that? That is a minus b, a plus b, again. And so that would be what? That would be y minus 2, y plus 2, because this is y and 2 right here. So the y would go here and here, and the 2 would go there and there. So we get y minus 2 and y plus 2. Now those two brackets, you got to check and see if those factor any further. Okay? They do not, because they each have two terms and they have y to the first power. And remember, when you have a bracket, okay, and it's got two terms with y to the first power, that does not break down to two more brackets. All right, that does not break down to two more brackets. Again, two terms variable to the first power, that's not going to break down. It will not fit into this, in other words. Okay. Now this one right here, I'm just going to write it down here, all right? You don't have to rewrite it, but I'm just going to write it down here so it'll be next to the other denominator there. When, just a reminder here again, we have when you have a term times a bracket already, you know they already did the factoring for you. Okay, it looks like they factored out a GCF already. When you have a term times a bracket, just check to see if the bracket can be factored any further. You don't need to do anything else, because it looks like they've done some of the factoring for you already, if not all of it. So y plus 2, again, that's got two terms in the bracket with y to the first power. Again, two terms with y to the first power. It doesn't fit into this formula. And so that is prime. It does not break down to two brackets, in other words. Okay, meaning that bracket is prime. And so that, again, a reminder, when you have just a term times a bracket, it's a green and a red. Remember, green is the single term ones, usually a GCF. Okay, and then the red ones are usually they're in a bracket, not always, usually they're in a bracket, but the key thing is that they are when you have more than one term. Okay, and remember, when you have just two brackets being multiplied together in a denominator, that's two brackets. I'm sorry, that's two red ones. When you have two brackets and that's it, that's just two red ones. And again, when you have a term times a bracket, that's a green and a red. Okay, that's all important because the way you treat green, just like when you put fractions in lowest terms, okay, the way you treat green is differently than the way you treat red. Okay, you can only cancel green with green. You can only cancel red with red. It's the same idea here where you keep the green and the red separate from each other. But you don't do any canceling, though. Okay, what you do is you look at the green first and you find the least common denominator or least common multiple of the green factors. However, there is only one green factor, so when that's the case, you just put that into the LCD. Again, if there's just a single green one, you just put that into the LCD. Okay, if there had been two green ones, then you would find the LCD in the same way we did here for these ones, because these are single terms also. We'll get to an example like that in just a moment. Okay, now what we do, now that I'm done with the green, I now go to the red part. And listen carefully here. It says list out, and this is for the red part right here. Okay, this is looking at the red ones. All right, step 3 up here where it says find the LCM of the single term factors. That's the green ones. Okay, but now we're on the part where it's the red ones. It says list out each of the different ones. How many? You see we have 3 of them here, right? But there's only 2 different ones because 2 of them are the same. The 2 different ones are y minus 2 and y plus 2, and then y plus 2 repeats over here. So what you do is you just put all of the different ones into the LCD. Do not just put all 3 of them in there. You got to put all of the different ones in there. That's the key. That's for the red part. Okay, so for the green part, you find the least common multiple, or you can call it least common denominator, of all of the green ones. But if there's just one, you just put it in there. And then for the red part, you just put all of the different red ones in there. Now, there is an exception to that, okay, which I'll show you in the next problem. There's an exception to that whole thing where you just put all the different ones in there for the red ones. Okay, it's kind of rare, but it happens sometimes. I'll show you that right now. And it'll still be consistent with what we're doing here. It's just I just need to explain an additional thing there. Okay, so let's go to the next one and we'll talk about that. X squared minus 25, the GCF is 1. Okay. However, this is x squared minus 5 squared, isn't it? So it fits into that formula again. X squared minus 5 squared, follow me here. X squared minus 5 squared is x minus 5, x plus 5. Okay, so that's going to be x minus 5, x plus 5. We are now done factoring that. Okay, for the same reasons as before, we have each bracket has 2 terms with the variable to the first power. You can't do anything with that. Okay. Now this one looks like the Berry method because you have x squared, x to the first power, and then the constant number here, no variable here. So that's the Berry method. Okay, we say 1 times 25 is equal to 25, and then we need to find 2 pairs of factors for 25 that multiply together to equal 25, but they also add up to negative 10. Wouldn't that be a negative 5 and negative 5? Okay, so if you know it right away, you can just figure it out. Otherwise, make the list, okay, until you find a pair, if the pair does work, that will equal negative 10. So since that's the case, we're going to say x minus 5 and x minus 5. You put minus 5 in both of those there. 1x squared gives you 1x and 1x. These cannot be broken down any further. And so we get 2 red ones there as well. Again, 2 brackets with more than one term inside of each one of them. That means you've got 2 red ones there. Okay, so here's what you do. You look at each of your 2 denominators. There's no green ones, so we can skip the green step there. Okay, we'll see more green ones here in problem D. We'll kind of get more used to that. But then we go to the red part. It says list out all each of the different multiple term factors. There's 2 different ones, isn't there? X plus 5 and x minus 5. Okay. There's a total of 4 of them, but 3 of them repeat, right? X minus 5 repeats 3 times. There's a total of 2 different ones. It doesn't matter which one you put first here, either x minus 5 or x plus 5, because they're being multiplied. Okay. So you could have said x minus 5 first and then x plus 5. But we're not done yet. Here's the thing. It says if a multiple term factor appears more than one time in the same denominator, then you listed out the greatest number of times it appears. So let me show you what I mean by that. Notice that x plus 5 appears once here. It appears once here because it appears once here, and then x minus 5 appears once there. Okay, so x plus 5 appears once, and x minus 5 appears once in this denominator. But notice this one here, x minus 5 appears twice in this one. So let's review here. X minus 5 appears once here, x minus 5 appears twice. Okay, x plus 5 appears once here and none here. Okay, unless the same red one appears more than once in the same denominator, you just do what we did in the last problem, which is just to put all the different ones in there. Okay, but if you have one of these situations where the same one appears more than once in the same denominator, I don't mean the whole thing, all 4 of them. I'm talking about in the same denominator. If it appears more than once, like x minus 5 appears twice in the same denominator, that means you got to put it in the answer twice. Okay, so let's review here how to do red ones. Okay, you always, and I'll get to the exception here in a second, you always put all of the different ones into the denominator. We had 2 different ones here, I put them in there. We had 2 different ones here, I put them in here in these first 2 brackets. But if you do have a red one that does appear more than once in the same denominator, you do put it in the answer however many times it appeared maximum. Okay, what I mean by that is x minus 5 appeared once here but twice here. So the maximum number of times it appeared was once, twice, right? Twice. And so you put it in the answer twice. So that's the exception. So unless a red one appears more than once in the same place, you just do what we did in problem B, which is just to put all the different ones in there, and that's it. Okay, you still put all the different ones in there. It's just that you tack on an additional red one if it appears twice, if that same red one appears twice in the same denominator. That's the exception right there. Okay, all right. But yeah, otherwise you just put the red ones. You just only put all the different ones into the LCD. Okay. Last one here. There's a GCF in both of these. They've both got more than one term because of the plus and minus, so we have to factor. Okay. Factoring out the GCF, we get that. Factoring out the GCF here, we get this. Okay. Remember, when you have a GCF times a bracket, it's going to be a green one and a red one. Same thing here. I'm sorry, I messed up there, didn't I? I didn't mean to write that 10 right there. I'm sorry, I didn't mean to write the X right there. Excuse me. There we go. There we go. So that again is a green one and a red one because of the GCF. So here's what we do. As we've been saying all along here in this lesson, you do the green and red separately. So for the green, because there's more than one of them, we find the greatest common sorry, not greatest common factor. We're doing LCD here, my bad. So we find the least common denominator or least common multiple of 5 and 10. Just like up here with 15 and 24, because these were single terms as well, you take the bigger number between 5 and 10, just like we took the bigger number here, 24, and you list out the multiples of 10, 10 times 1, 10 times 2, 10 times 3, and you keep on going until you find one that's also a multiple of 5. Well, isn't 10, I actually didn't even need to say these two numbers because 10 works, doesn't it? 10 divided by 5, just like 120 divided by 15, okay, that works, all right? 10 divided by 5 does divide evenly, and so 10 will be part of the LCD here. So again, you keep on listing them until you find one that works for the other green one, but the first one does. 10 works. Okay, so we put that in there. Then once again, notice that unlike the last problem, we don't have a red one that appears, we don't have a situation where the same red one appears twice in the same place. Okay, so with the exception of that situation, you just put all the different ones into the LCD. So we have x plus 5 and x minus 3. Those are the two different red ones that we have, correct? Okay, and that's all we have. It's just those two. So putting out all the different ones into the LCD, okay, we're now done with the red ones, and therefore we're done with the LCD right there. Okay, these LCDs are that's gonna be how you're gonna figure out how to write the denominator so that it's the same when it's not the same. Because you can see down here, as I mentioned at the beginning of the video, you need to make these denominators the same. Okay. Let's look at this first example here. I didn't type it down onto the worksheet, but we'll do it off to the side right here. Let's try this problem right here. We're subtracting two fractions. The denominators are not the same. However, it's the same two denominators that we have up here when we pretended like these were denominators. And we found out that the LCD was 120x squared. So no need to figure that out again. We'll just use that now. So I'm going to do 11 over 15x squared minus 7 over 24x. Okay, I'm going to write it down off to the side here. I'm going to write it in a vertical format up and down there. That's what a lot of students prefer. It doesn't mean you have to do it that way. Okay. But what we need to do, no matter how you write it, what we need to do is we need to multiply by something in order to make both of the denominators equal to the LCD 120x squared. So I'm going to write down the correct denominator over here that we want, which is 120x squared. So we need to multiply by something in order to make the denominator change from 15x squared to 120x squared, and also from 24x to 120x squared. How are we going to do that? It's kind of like doing a GCF problem. Okay, I know we're doing LCD right now, but it's a similar thing when we do the multiplication part here. All right, if you factor 15x squared out of something, what do you have to multiply by to get it to equal 120x squared? Okay, well, when you figure out what you have to multiply by to get it equal to something, you look at each part. You look at the coefficient and you say 15 times what is equal to 120, and then you look at x squared times what is equal to x squared. One thing at a time here. 15 times what is 120. Okay. 15 times what equal to something? That's a division problem where you take the answer, 120, and you divide it by the thing that you know over here that you're multiplying by. So if you put that in your calculator, 120 divided by 15, that's going to be equal to 8. Now, do not multiply by any x this time, because just like when you're doing GCF, if you factor out the same exponent as you already have, okay, then you don't want to put an x here. Even if you just put x to the first, that would make this x to the third, and it's supposed to be x to the second. So if the exponents again are the same, you just you don't do the x part. Now, whenever you so we're just going to multiply by 8 right there. Whenever you multiply the bottom by something, though, you guys, you got to multiply the top by the same thing. And so 11 times 8 is 88. How about down here? 24 times what is going to give me 120, and then we'll do x times what equal to x squared. Okay, 24, we got to say 120 divided by 24 in our calculator. It will tell us that 5 is that missing thing that you got to multiply by there. Okay, 24 times 5 is 120. However, now we have x to the first and x to the second. Remember, when you multiply terms together, okay, you have to add the exponents if the letters are the same, like these two are. And so x to the first, we must need another x to the first right here, okay, because 1 plus 1 is 2. All right, so 5x to the first is the correct variable there. Okay, it has to be x to the first, all right, because 1 plus 1 is 2. So 5x is what we're going to multiply by. That means we got to multiply the top by 5x. Okay. Don't mix in the minus with the 7 here. Okay. Just multiply by 7. We'll talk about how to deal with the minus here in a second. Okay. So don't do negative 7 times 5. Just do 7 times 5x. Excuse me. Don't do negative 7 times 5x. So we got 35x. Now we are ready, you guys, since the denominators are the same now. These two fractions are equivalent to the original fractions. So it's still the same problem. It's just that we've now converted the denominators so that they'd be the same. Now that they are, you can now subtract the numerators. Now, remember, you guys, when you subtract two terms, that doesn't mean you can combine them. Okay? If you have two terms that are not like terms, which these aren't, okay, and you're asked to subtract them, that doesn't mean you combine them. Don't do 88 minus 35 when these aren't like terms. If they're not like terms and you're asked to subtract them, what you can do and what you should do is not combine them, but you should say that they're being subtracted like that without actually combining them into one term. Okay, so if you're adding or subtracting two terms that aren't like terms, you can still say that they're being added or subtracted, in this case subtraction, okay, without actually combining them. I know it looks kind of weird because it looks like we didn't do anything, but we did do something, and that is to make this into one fraction. That's the whole goal of adding and subtracting fractions, is to take the two fractions and to make them into one fraction. Okay, by saying 88 minus 35x together like that, without combining them, we can make a single fraction, a big fraction, bigger anyway, but it's still a single fraction. Okay. All right. And so that is a little bit of a warm-up there when we're doing single term denominators. That's how you add and subtract fractions. Okay, let's take a look at the bigger denominators. Now, notice this one is plus and this one is minus. It's going to be a big difference. But with the exception of that plus and minus, the steps are basically going to be the same in both problems. Okay, the first thing we need to do is we need to find the least common denominator. Okay, I'm going to go ahead and set up this vertical format again here just to get us started with that right away. And at the same time as I'm doing that, I am going to factor both of my denominators. Remember, I have to factor when I have more than one term in my denominators in order to figure out what the LCD is. So at the same time that I'm setting up my vertical format here, okay, I'm going to factor my denominators here, okay. So I'm going to factor my denominators underneath the 7x. There's the 7x right there. Underneath the 7x and the 3, I'm going to put the new denominators underneath that after I factor these denominators. Then I'll know what the LCD is. Okay, this is the Berry method here. We need two numbers that equal -8 when we multiply them. Okay, but they need to add up to 2 right there. How about -2 and 4? That would work. So we're going to get x minus 2 and x plus 4. Okay. In the same respect, 1 times 2 right here, we're doing the Berry method because of how these denominators look right here. They need to add up to -3, but they got to multiply together to equal 2. How about -1 and -2? That would work. Okay, so that's going to be x minus 1 and x minus 2. So both of these denominators have just 2 red ones in them because they're just 2 brackets and that's it. Can you see what the LCD is based on what we just learned at the top of the worksheet? Okay. The LCD is going to be, again, there's no green one, so you skip that step. But then when you do the red part, you put all of the what? You put all of the different red ones into the answer. And this is not one of those problems where you have the same red one appear more than once in the same denominator. So you just put all the different ones in there. Okay. Doesn't matter what order that you put them in because they're all going to be multiplied together. Okay. When you list out your red ones in your LCD, you say that they're being multiplied. So you don't put anything in between the brackets. And that right there, you guys, is the LCD. Notice I already put it in my new denominator here over on the right, just like I did in this problem over here that we just did. I put it over on the right because I know I need to transform the answer so that the denominator looks like the LCD. Okay, so I'm putting all of the different red ones into the answer, into the LCD, I mean. Okay. So I need to take these two fractions, I need to transform them so that they look like two fractions that have the LCD on the bottom. How do I do that? Well, notice that in each case here, let's start out with the first one. You have 3 red ones in your LCD. 2 of those 3 are already in your current denominator that you already have. So wouldn't it make sense to multiply by the missing one there? Notice here we have x minus 2 and x plus 4 already in the LCD. X minus 1 is the missing one. So if we multiply by x minus 1, it will then give us the LCD right here. So just like over here, you have to multiply by the appropriate thing so that it's equal to the new denominator. Same thing here. You multiply by x minus 1 and it'll do that. It'll then be equal to this. So if you multiply the bottom by something, you got to multiply the top by something. Okay, now this is especially important here because you got a single term being multiplied by 2 terms here. Just a reminder again, when you are multiplying something that has more than one term in it by something else other than the number 1, that would be different. 7x is not the number 1, obviously, so that would count here. When you're multiplying 7x times something with more than one term in it, you got to bracket this thing because you got to multiply by this whole thing. Then what you need to do at this point is because we're eventually going to try to combine like terms when we make the denominators the same, you want to get rid of the parentheses on the top, not on the bottom. The bottom you can keep the parentheses. On the top you need to get rid of the parentheses so that you'll be able to at least attempt to combine like terms. Okay? The way you get rid of those parentheses when you have a term times a bracket is to distribute like this. 7x times x is 7x squared. 7x times negative 1 is negative 7x, like that. And then let's do the same thing now in the second denominator, but we made, or with the second fraction, but we made the denominator equal to LCD now. Okay, notice that x minus 1 and x minus 2 are already in the LCD right here, first and last one. Doesn't matter what order they're in, okay? As long as you multiply by the missing one here, the missing one is x plus 4. Rest assured, you guys, these 3 things right here, even though they're in a different order than these because they're all being multiplied together, these 3 brackets are equivalent to these 3. Okay, so don't worry about the fact that they're in a different order. Okay, it's still the same thing. Okay, even though they're in a different order because of the multiplication. The point is, though, is that we need to multiply by the missing thing, just like we did up here, multiply by the missing red one, the missing bracket. And then we have to multiply the top by the same thing. Okay? And so, just like up here, we want to get rid of the parentheses in the top of each fraction so that we'll be able to try to combine like terms. Okay, 3 times x is 3x. 3 times 4 is 12. It's positive 12, so put the 12 there. Okay, now, just like we did over here, now we try to combine like terms because when you're adding and subtracting numerators, okay, here we're adding, over here we were subtracting. When you're adding and subtracting numerators that have regular terms in them, the goal is to combine like terms as much as you can. Here we weren't able to, so we did what we wrote down here. Here there is one pair of like terms, but the other two terms, 7x squared and 12, are not. So what we'll do is, and what you need to do is we're going to need to try to factor the numerator, because we're going to need to try to simplify the resulting fraction into lowest terms. That means we're going to need to try to do some more factoring here at the end. Okay, so when you have x squared, x, and then no x at all, if you have those three different types of terms in your numerators, after you've cleared out the parentheses in the numerators, you then put it in that order, x squared, x, and then no x at all, when you write it down, so you can try to factor it using the Berry method, because the Berry method is always in this order, isn't it? X squared, x, and then no x at all. So when I combine like terms, I'm going to bring down the 7x squared first, since that doesn't combine with anything. Again, we're just combining these four terms here on the tops of each fraction. And then the negative 7x and positive 3x equals negative 4x when you combine like terms right there. Negative 7 plus 3 is negative 4. And then plus 12 didn't combine with anything, so that just comes down. But we put it in that order so that it looks like the Berry method. Remember, just like in the problem we did over here, when the denominator is the same, it then stays the same when you combine the numerators together by combining like terms as much as you can. Okay? Now we take this and we try to put it in lowest terms. Putting it in lowest terms means to factor the top and bottom and then try to cancel whatever you can. Now, if you do the normal thing that I'm showing you here for the LCD should already be factored. You don't need to factor it again. And when you have three brackets, no terms on the outside, no GCFs or anything, you just got three brackets with more than one term inside of each. That's three red ones right there. Okay? So just a reminder of when you are simplifying or putting it in lowest terms, as we see here from a different video, different worksheet, all right, you identify your reds and greens and you cancel what you can, okay? And we are allowed to cancel red ones if they are exactly the same here. Okay, it's also true that if you have a polynomial like x plus 1 that's prime, that's just one big red one. Okay, meaning the GCF is 1 and you can't break it down to two brackets. That's exactly what happens with the 7x squared minus 4x plus 12. Okay, it's got a GCF of 1, and if you try to do the Berry method on that, you do 7 times 12 is 84. Okay, but there are no, you can try it if you want, but if you list out all the pairs of factors for 84, you will not find a pair that adds up to negative 4. Because that's the case, you cannot break this down to two brackets using the Berry method. And so, because that's prime, due to the fact that the GCF is 1 and you can't break it down to two brackets, that's one big red one, just like the x plus 1 in that other worksheet was. Okay? And so, it's also true from combining, when you have to put something in lowest terms, what's also true is that when it's red, you can only cancel if there's a red one on the bottom and the top that are exactly the same. Obviously, this one on top is nowhere near the same as any of these three red ones on the bottom. Okay? Okay. It's also true, again, that when you put in lowest terms and you have a bunch of red ones here, that if they're exactly the same, you can cancel. There's this one other exception, which you're not going to see here in this current video that we're doing. But if they are exactly the same, that's what I want you to watch out for. All right. However, these are not, again, none of these are the same. Okay. So here they were, x plus 1 and x plus 1, we were allowed to cancel. Here we don't have that situation. Okay, so we can circle that, nothing canceled. Okay, the goal of simplifying into lowest terms is to try to cancel something. If nothing cancels after you've factored everything that you possibly can, then you can stop. Okay, let's do that once again here in problem B. This time, however, we are subtracting, which leads to one very important step that's different. However, And let me give myself a little bit more room here as I'm talking. So there is one big difference here. Okay. It's going to be on the step where you have to combine like terms. Okay. Because that's a step where you either add or subtract the numerators. Here we are adding the numerators. Here we're subtracting. Okay. When you're subtracting the numerators, you do more than just combine like terms. There's one additional thing you got to do. Whereas when you're adding, you just have to combine like terms. Okay. But we're not at that step yet. We still got to figure out what the LCD is. Okay. So again, x squared plus 3x minus 10, that looks like a Berry method problem. Okay, negative 10. What adds up to 3 out of negative 10? That would be 2 and, negative 2 and 5, wouldn't it? So that would be x minus 2 and x plus 5 on the Berry method. Now, again, if you got two brackets as your denominator, that's two red ones if they both have two terms in them. This right here is a prime red one right there because it's got two terms and it has a GCF of 1 and it doesn't break down to more than one bracket. So what do we have as far as an LCD right here, you guys? We have, again, no green ones, so you can skip the green step, but we do have two different red ones. We have a total of 3 red ones, but again, we only put all the different ones into the answer here for the LCD. Again, unless you have one of those situations that we saw earlier where the same red one appears twice in the same denominator. That doesn't happen here. And so you just put all the different ones in there. Now, good news. This denominator is already the same as the LCD, so you don't need to multiply by anything. If it's already the same, don't multiply. Okay, it's kind of like x squared and x squared, right? We didn't multiply by another x right there. We had to multiply by 8 to change the 15 to 120, but the x squared did not need to be changed, so we didn't multiply by another x. It's the same thing here. The two brackets here are the same as the two brackets here. Okay, it's already the same. Don't multiply by anything. So because of that, we're also not going to multiply the top by anything, and therefore the top stays the same also. So if the bottom already is the LCD, then the top will stay the same as well. However, on this problem, or on this second fraction rather, just like we were talking about in the last problem, you have two red ones in the LCD. Okay, one of those two is already sitting. I know it's not in a bracket, okay, but it's still a red one, as you can see there. So one of those two is already there, so it would make sense that you multiply by the other one. Okay. When you have just a single red one in a denominator, and even though it doesn't have a bracket in it, when you multiply by another bracket, it's implied that there's like an invisible bracket around that. Because when you multiply a denominator by something, you've got to multiply the whole thing. And that means that there's like an invisible bracket around it. You don't have to write it until you get over here. Why do I got to write it over here? It's because when you multiply something with more than one term in it by something else, as I mentioned earlier, you got to bracket it. But you don't have to bracket it if it is the only thing in that denominator. It's already implied that you have to that there's an invisible bracket there. But now that it's joining another bracket in the new denominator, you now have to bracket it. So if it's by itself, you don't need to bracket it. Okay. When it joins something else that it's multiplying by in the same denominator, you now need to bracket that to make it clear. Because if you don't put that bracket there, it's going to look like you're multiplying by just the negative 2, since that's the closest term to x plus 5. Okay. But when you look at a denominator with just a single red one by itself, all right, it's already implied that there's an invisible bracket there. Okay, so we got to multiply the top by the same thing. Same idea here, you guys. This is a single red one here. Okay, not that we were trying to factor it, but it's the same thing here. It's just a polynomial. Okay, when you have just a single polynomial, okay, no brackets or anything, All right, it's like there's an invisible bracket around that. I'm going to actually, and you could do it down here with the x minus 2. You can make the invisible visible, okay, just to make it easier on you. Okay, but there is, when you have just a polynomial, no brackets, and it's got more than one term in your numerator, okay, because you're multiplying something with more than one term in it, x minus 7 has got 2 terms. Because you're multiplying by something, you have to bracket it. Okay, I know I've said that a number of times now, but I can't say it enough. It's so important. Okay, so that reminds us that we have to multiply this whole thing, not just the negative 7, but this whole thing by x plus 5. Now, how do I multiply 2 brackets together like that each have more than one term in them? Just a reminder here from a different video, when you have a bracket times a bracket and they each have 2 terms in them, okay, you do the first term in the first bracket multiplied by each term in the next one, and then the second term in that bracket you multiply that through as well, for a total of 4 multiplications, 4 terms down here. Okay, so let's try that here. X times x, x times 5, and then we'll do negative 7 times x and negative 7 times 5. So we get what? We get x times x is x squared, x times 5 is positive 5x, x times negative 7 is negative 7x, and then negative 7 times 5 is negative 35. Now here's the really important part, you guys. Because this is a subtraction problem, subtracting fractions, okay? After you clear out those parentheses, and which is what we got to do with the numerators, like we said, so that we can try to combine like terms, you need to change signs before what? Before combining like terms. Okay? Okay, that's because why? Why did we not do that in the last problem? Because this problem is a subtraction problem. The other problem was addition. Okay? So what we do then is we change all of these, their signs. So notice here this is positive, positive, negative, negative. So we're going to change it to negative, negative, positive, positive. Now you can combine like terms. Okay? And so when you combine like terms, all right, what do we get here? The x squared and the x squared. It's basically become an addition problem when you do that. Okay, so you're not doing x squared minus negative x squared. You're not doing that. It's basically an addition problem. In other words, you're just combining like terms now that you've changed the signs. So you change the signs, then combine like terms when it's a subtraction problem. X squared and x squared cancel out. Negative 5x and 7x become 2x. Negative 39 plus 35 is equal to negative 4. And then that's it, because the x squared's canceled out. Okay? So that's our new numerator here. And the bottom is x minus 2x plus 5. We then try to factor the, again, just like in the last problem, we got to try to factor everything to see if something cancels, to put it into lower terms if that's possible. The denominator should already be factored, because if you do the LCD in the normal way here, it should already be in factored form, where you either have like 3 brackets or 2 brackets being multiplied. Okay, and as we've seen many times, when you have 2 brackets being multiplied, that's 2 red ones there. Okay, so figure out what you have in the denominator. Again, if you got 3 brackets, that's 3 red ones. If you got 2 brackets, that's 2 red ones. Okay, but I can factor this numerator, can't I? Remember, I've got it factored if it's factorable, if it's able to be factored, if it's not prime. That's got a GCF of 2. And then the x minus 2 is prime, meaning you can't break that down to 2 brackets because it's got 2 terms and it has x to the first power. 2 terms and x to the first power can't break that down. So that gives me, as always, that gives me a green and a red when you factor out the GCF. Okay, and if it's just, if the bracket doesn't break down any further, it's just going to be that single red one. In the bottom, again, it's still two red ones here. Can I cancel something? Remember, when you're canceling, you cannot do green with red, so you can't do 2 and 2 right here. But you're allowed to do red and red if they are the same. These two are exactly the same, so they become 1 and 1. And now I'm in the process of putting in lowest terms. Okay, I have 2 times 1 on the top now. And on the bottom, I have 1 times this bracket. And remember, when you have 1, as long as it's positive 1, if you have 1 times a bracket, okay, you can just say the inside of the bracket. You could keep the bracket there if you want, but you don't have to. And there you go. That's your final answer. So let's go through it again here. When you're adding and subtracting fractions, you find the LCD. You multiply by the appropriate things to make the old denominators equal the LCD here. Then, if it's an addition problem, you just combine like terms after you clear out the brackets on the top so that you can combine like terms. If it's a subtraction problem, remember after you clear out those brackets on the top, you got to change the signs of only the second one. Do not change these ones. Only the second one, the one that's being subtracted. We're doing first minus second, so it's the second one being subtracted. Change the signs of only the second ones before you combine like terms. Otherwise, it's the same as this over here, other than the sign changing on the one that's being subtracted. Then at the end, try to put it in lowest terms. Okay, if it doesn't go into lower terms, that's fine. Leave it the way it is. If it does, then you got to do that. Okay. So that is adding and subtracting fractions. Okay, and that concludes our video, not only on adding and subtracting fractions, but also on how to find the least common denominator.